All right, another video on integration by parts. What we're going to do in this video is we're going to use this exact same formula, the integral of u dv equals uv minus the integral of v du. And yes, I'm repeating that on purpose over and over again every time I use it to try to hammer it into your head. At any rate, we're going to use this exact same formula, but we're going to use it in some kind of weird cases. Some cases that maybe you wouldn't expect to use it. And the logic here is the same as what we've seen in the past. You should never think to use it in these cases, but there's only so many. So if I show you them, then anytime you encounter something similar, you kind of have this in the back of your mind and maybe you can get past it, even though you never would have thought to use it originally. So the first of these tricky examples is if you're ever asked to figure out the antiderivative of the natural log of x. You're like, wait, what? Just the natural log of x? Like not the natural log of x times something, just the natural log of x? That can't possibly be integration by parts because integration by parts only works when you have something times something. I know it's counterintuitive, but that formula will work here. And the first point that I want to make is the answer is not going to be 1 over x. And that's because the derivative of natural log of x as opposed to the antiderivative is 1 over x. But a lot of people confuse that, so I wanted to point that out. The second thing is you're like, all right, integration by parts. I learned how to do that in the last video or videos. Step 1, determine what u should be. Well, I don't really have a lot of options, right? U has to be something and then dv has to be everything else, but I only have one thing. So how's that going to work? Well, I guess the trick is to think about this as though it's the natural log of x times 1, right? You kind of have this 1 as a placeholder that you can use anytime you want. You're like, all right, that's weird. Which of those two things, the 1 or the natural log of x, should I choose to be u? Well, think about it. If you made your u the 1, the placeholder, then the dv would be the natural log of x. And you'd be like, all right, dv is natural log of x. I have to figure out what v is. Well, v is the antiderivative of dv, so v would be the antiderivative of natural log of x, which is exactly what the question's asking. We're kind of going around in circles. We couldn't do that because we don't know the answer to the question because we haven't solved the question, so we can't do the question that way. So sort of by process of elimination, I'll let u be equal to the natural log of x, and that'll leave me as a dv just the 1 dx. And you can write the 1 as a placeholder if you want, or you can just leave it as dx. Either way is fine. Maybe I'll leave the 1 for now. More standard is to not write the 1, but maybe the first time around it'll be easier for you to do your anti-differentiation if I leave this placeholder here. At any rate, when u is the natural log of x, we could figure out du. Du over dx would be 1 over x, so therefore du would be 1 over x dx. And v, the antiderivative of 1? That's kind of a strange question. What would I have to take the derivative of? Oh, that's easy. That would just be x, right? V must be equal to x because the derivative of x would just leave me with this 1 up here. All right, I think I have all the pieces. It still feels kind of strange. But let's see what happens when I plug these into my formula. Again, the formula tells you what the integral of u times dv is. Let's check that we got that right. U is natural log of x, dv is 1 dx. So natural log of x dx, oh good, that's what this is going to tell me. That's equal to u times v. Well, u is the natural log of x and v is x. So I got x natural log of x minus the integral of v du. Well, the v was the x, and du is 1 over x dx. X times 1 over x dx. But wait a minute, x times 1 over x, isn't that just 1? Yup. So I get that this is x natural log of x minus the antiderivative of 1, which you don't even need to write. You can just write dx if you want. What's the antiderivative of 1? Well, don't forget you've already done that. You figured out that the antiderivative of 1 is just x. What I get is this is x times the natural log of x minus x, and then if you can think of it, add on the plus c. Kind of weird, right? I mean, not as hard as the examples we did in the past, just super counterintuitive. You probably wouldn't have thought to let just a 1 as a placeholder take the role of dv, but that works. In fact, that works in a couple different cases. When it works is when you're trying to find the antiderivative of something, and that something, you don't know the antiderivative of it, but you do know the derivative of it, and the derivative of it pairs well, loosely speaking, with an x, which is what you'll get for your value of v if your dv is just the 1 as a placeholder. And maybe that's a little bit too abstract for you to ever take this anywhere. I think what you'll see on your homework is there is a question where you have to figure out the antiderivative of arctangent of x. And you're like, 1 over 1 plus x squared. No, that's the derivative of arctangent of x. You don't know the antiderivative of arctangent of x, but you can do a trick just like we did here if you let u be equal to arctangent of x. Because you do know the derivative of arctangent of x, that's that 1 over 1 plus x squared. And then your dv is just a placeholder, your v, do a little bit of work, maybe do a u substitution at the end, and you'll be able to make this work. That works for both arctangent and arcsine, both of which I believe you're asked on the homework.